This conference will now be recorded.
So guys, let's see dynamic programming part 2. So we are going to now solve one more problem statement. So here we're gonna understand how the knapsack problem statement can be solved for us. So yesterday we did two techniques, right? So we did what is memoization and what is tabulation, right? So there are two different ways to solve a problem statement through dynamic programming. Either you go with the memoization or you go with the tabulation, right? So what problem we have to come up and see today is this knapsack problem. So you'll be given some weights and their profits along with the capacity. So our goal is to select the items from the knapsack, right? And each item can be selected only once. So we don't have multiple quantities of any item. So you need to pick one item, right? You need to work on the combinations of the item, right? And you need to see if the combinations of item with your knapsack capacity matches. So you need to find out the maximum profit out of it. So we have already solved this problem statement. I hope you can recall. We generated some combinations and we solved the same problem, guys. Can I get an acknowledgement to the smiley from everyone? So guys, I hope we have solved the same problem. Right. So the next part of our discussion is where we got these items, right? So we got apple, orange, banana, and the melon. There are some weights, right? And there are some profits with respect to them. So the knapsack capacity is 5. So what are those items which you will be picking up so that it can make the best combination, right? So here we are. If you pick apple and orange, the total weight is 5, so it's gonna be 9 as in your profit. So your apple and banana is gonna be 3, which is 7 profit. Orange plus banana is gonna be 4, which is the profit 8. Then banana plus melon is going to be 5 with the profit 10. So this is where you have to hit and say that okay, banana plus melon is the best combination as it is going to give you the maximum profit and the total weight does not exceed the capacity. So guys, can I get a smiley? Are we good to go here? So in order to solve this problem with the recursive approach, right? So what we're gonna do is we're gonna apply a brute force algorithm. We're gonna use some recursive approach and we're gonna apply a brute force algorithm where we'll try to solve it. We'll just change the technique to solve the same problem, right? So last time we solved it with some better way, as in we implemented something known as combinations. We generated the combinations, and with the help of combination, we solved the problem. But what we're gonna do today is something different. Let's see how. So there is a set of items, a list of items A, B, C, and D. We got the profits 1, 6, 10, 16, and the weights 1, 2, 3, 5 with the given capacity for us as 7, right? So we need to solve this problem. So how you will be solving it? We'll begin where we have this data for us, values A, B, C, D. Then a selected list will be empty. Profit is 0 and weight is 0. We'll start by considering one single value A. We'll select the value A and we'll check for the profit and the weight. So in the right side, you skip the value A and you proceed with B, C, and D. So typically for every iteration, we are going to select one element, skip one element, and then check what exactly is going to be the weights and the profits. So in the end, what you will be able to get is that you have your selected values, profit and the weight. Selected values, profit and the weight. Guys, please try to see the image and see in case it works for you guys or not. Please acknowledge me with a smiley in case we are good to go here. So guys, are we clear here with the algorithmic approach? Now this is where we understand that the bigger problem is divided into sub problems, and there are overlapping sub problems, right? Once again, you find that there are overlapping sub problems, so we can implement dynamic programming. So let's try to come up and write an algorithm where we can solve a knapsack problem with the brute force algorithmic approach. But here we are not going to apply our dynamic programming. All right. So first of all, let's have a basic solution. So we're going to have a basic recursive solution. All right, guys. So what we got some list of items with their. Just give me a moment here. So we have these profits and the weights 1, 6, 10, 16, and 1, 2, 3, 5, and the capacity. So profits 1, 6, 10, 16. Weights are 1, 2, 3, and 5. And the knapsack capacity is basically coming up as 7 for us here, right? So this is what we have to evaluate, right? Items, profit, weight, and capacity. So items I'm not considering. If you want, you can have them, but it's okay. So these are the three lists as inputs which are available to us. So if you want to solve it, so I'm gonna begin with the solution, right? So let's say define knapsack. So I'm going to take profits as input. Then I'm gonna take weights as input, and then I'm gonna take this capacity as input. So we are going to execute a function, right? And in order to execute a function, so let's call it and pass these values: profits, weights, and capacity. So guys, I will write one more function called define knapsack solution. So this function takes all these inputs: profits, weights, capacity, but this guy will also take one more input, right? So this input is kind of a variable called current index, from where you're gonna begin solve your problem, right? So here in the knapsack, I will say return me the knapsack solution with the profits, weights, capacity, and the current index is 0, right? So we're gonna begin solving the problem from the current index as 0. So this is again an indirect recursion where you're going to have one function calling the other function, and this function will call itself again and again. So guys, can I get a smiley from all of you? All right, so in this very basic problem approach, if you will observe here, so you are basically selecting one element and skipping one element, right? So there is selected list, right? So you evaluate the profit and the weight. So two things you are evaluating: profit and the weight, by selecting one element and by skipping one element. So what I need to do is I need to evaluate two profits. So we need to compute two profits, one by selecting the element, another by skipping the element, in order to solve this problem, right? So I'll evaluate this by saying profit 1. So by default it is 0, and we're gonna come up here and say that your profit 1 is basically your profits of current index, which you have actually kind of given, and I'm going to come here and execute this fellow plus the knapsack solution. So the current index profit, that's like 1, right, will be added here, if you'll see. Thereafter what I'm gonna do is I'm gonna come here and say knapsack solution. So guys, you passed your profits, then the weight. Now next is what you're gonna pass your capacity, but you're gonna reduce this capacity from the weights of current index, because your capacity will decrease. I mean to say, you already considered the part of it, right? So 7 it was, right? So now the capacity should go as 6, because you actually considered one item, right? And you will increment your current index by 1. So guys, can I get a smiley here? What is this recursive solution which we have implemented here? So you are adding the current index profit, then you call your function recursively with the profits weights. So capacity will now go as 6, and you have a current index which is supposed to be incremented by 1, because previously you actually considered your current index to be 0, and now you are kind of incrementing this current index by 1. I hope guys this is clear. So we want to do this profit 1 computation only in case the weights at the current index should be less than and equal to the capacity. So you want to evaluate profit 1 with, of course, a condition, right? The condition is very basic, that we would like to come up and have it in case your total weight is less than the capacity. An acknowledgement awaited, guys, in case we are good to go here. So this is basically profit 1 by selecting the element. So this is by selecting the element. Now there is one more profit which you need to include, right? So by excluding the element. So when I'm saying excluding the element, right? So you are basically targeting the current index by selecting the element at current index and by excluding the element at current index. So guys, if I'm going to exclude the element at current index, so I'll just come here and say another profit 2 is going to be your knapsack solution, right? With the same data. So you're gonna consider the same data. So this is going to be your profits, weights. Then I'm going to pass the capacity. And then lastly, I'm going to pass this current index plus 1. So this becomes your second profit. And what I'm going to return is what is the max profit. So coming here, you see your max of profit 1 and the profit 2. So either you'll be, when I have divided this problem, guys, so when I have divided this problem here, correct? So at one part of time, what you are doing is, so Navlu, you can just have a look here. So have a look here, Navlu. So when you selected A, you kind of considered the weight, right? But when you have skipped A, the moment you skipped A, basically you reduced your list. Profits are 0, weights are 0, right? They are at the same level. So skipping, you don't touch your profit weight. If you see skip, don't touch profit weight. Don't touch profit weight. Same way, the moment you do a skip of B, you don't touch profit weight. Don't touch profit weight. Yes, so that is how the algorithm works for us. So let us come here and say max profit is, and you just say print max profit for profits with weights for capacity is. So let's say a dot of format. So I'm gonna just pass this profits, weights, capacity, and the max profit. Okay, so I think we have got something here and there. So just give me a moment. Let me do small cross check. So I just need to somehow stop the recursive program, right? So in case your capacity is going to be 0 or less than 0, since you are going to come up and decrease the capacity in your first case here, right? And there may be a case that your current index, the value of current index may go greater than or equal to the length of your anything, right? So let's say the length of your profits. So this is a base situation, right? So here you're gonna say return me 0. Base conditions for stopping your recursive program. All right, so here it says max profit for profits 1, 6, 10, 16 with the weights 1, 2, 3, 5, for capacity 7 is 22. So what we did here, we did a solution, right? And if you see here, so when you actually went for values B, C, and D, then you considered C and D, right? You got the values DB, right? So selecting D, B, and D made the profit of 22 with the weights as 7. So we consider our previous problem statement with a capacity 5, right? So we knew that with capacity 5, it was coming out to be 10 as the maximum profit. So change the capacity now. Let the capacity for us here go as 5. Okay, I think is the data same? Let's see. Or maybe the solution or the slides shall vary. No, it's not same, my bad. So 23144537. Just give me a moment. So 2314. These are the weights. Okay, profits are 4537. All right, so now run the code and let's change the capacity to 5. So here you are with the value 10, guys. Smiley waited with an acknowledgement from all of you guys. So you did say how you can solve an KnapSack problem statement with the recursive approach. Can I get a smiley as an acknowledgement from all of you? I'll just share this solution over the chat. So please just go ahead and review the same. So take a moment, review the solution, and let me know if you have any query, guys. So shall we resume, guys? All right, guys. So the next solution which we have to write is with the dynamic programming approach. So what I'm gonna do is I'm gonna implement this KnapSack solution with the memoization technique. So you guys implement the tabulation, okay? So let me take this entire solution. So for this part of our discussion, it's kind of, you can say, a brute force solution. So I'm gonna take down this entire program, right, and change this program into a dynamic programming structure. So we do understand that this kind of a problem statement is breaking your problem into multiple sub problems, right? At the same time, you have the solutions which are getting replicated again and again. So this follows your dynamic programming characteristics, and we can solve it with dynamic programming technique. So let's see, guys, how I can implement this in my this guy called KnapSack basic function. I'm gonna create a two-dimensional array, and I'm gonna put everything as -1 here, right? So what I'm expecting is, so let me show you here. So I'm gonna write a dynamic programming array, which is going to be a list of lists. So -1 for x in range of capacity plus 1, and here we got one list finished, right? And thereafter I'm gonna say for, let's say, y in range for the length of your profits. Let us print this a dynamic programming array, right? And in a better way, if you want me to print it in better way, so I'll say for row in dp, print me the row. So before I execute this function, right, I just want to show you that what is the kind of this array which we are going to make. So it's gonna be an array of array, right? So there are these 1, 2, 3, 4, right? And there are these 1, 2, 3, 4, 5, and 6. So guys, can I get an acknowledgement? So your capacity was 5. So you took one more solution, right? You have to consider 0, 1, 2, 3, 4, 5. There will be 6 combinations for the capacity part. 0, 1, 2, 3, 4, 5. And there are just 4 of the iterations, right? So you got this 2D array created. So this will be acting as a cache for me. So you're gonna create this dynamic programming memorization technique here. So now I'll pass this dynamic programming cache to the KnapSack solution as the first input, right? So create memorization cache for the solution. Now we're gonna pass the cache as first input itself. So dynamic programming is all about maintaining the cache here, right? So this guy will take the first input as this list of lists called db. Now this is not that challenging thing for us to understand, guys, right? So what you're gonna do is, whatever you were trying to save, you maintain it in your kind of, you can say, this array, right? So let us see how it can be taken care of. You evaluate the profit one, but there is now one basic change here, that when you will be recursively executing this guy, so you need to pass this cache again and again, so that if you have any solution, you should be able to save it. So guys, we'll see dynamic programming of the current index capacity should be this max profit. So this max profit 1, profit 2, basically you are going to save it in this current index and capacity, right? So you're gonna return this max profit. So anytime now your dynamic programming of cache, how it's gonna get, working for us. So it's gonna be like, so in case if your dynamic programming at the current index and the capacity which you're trying to solve is not equal to -1, right? Of course you have the solution for it then, because initial values are all -1, right? But in case it is not equal to -1, it means you have kept a solution here. So I'm gonna return back the dynamic programming of current index and capacity here itself. So in case we have a solution already existing for us, use the same and return from here. No need to do further computation. So guys, can I get a smiley from all of you? We'll try to solve the same problem once again now. So here we are, right? The output is same. And let us even solve this with our previous part. So exactly 22 coming up for us, right? So this is memoization technique where you are storing the data in your list. You are maintaining the kind of a cache. And guys, maintaining this cache is kind of majorly limited to lists and dictionaries, right? You're gonna store the data in the list and dictionary. Why? There's a reason to it. For this technique to maintain the cache, I will either use list or dictionary, because whenever I'm storing the data, if you see here, you are basically storing the result, right? So saving results in cache. So this is order of one. So when I'm going to consider, this is order of one. And similarly, when you're going to check for this guy, this is also your order of one. So fetching the data from this cache, or you can say saving the data in the cache, right? It is just going to be order of one for us. Hope this is clear to everyone, and we are good to go till here, guys. All right, guys. So what is the next big thing, right? So there are these top 50 dynamic programming challenges, right? And if you can see here, so longest common subsequences, substrings, then this guy called your knapsack problem here, right? Rod cutting problem, maximum product rod cutting problem, the coin change making problem. So these are the problems which, you know, great companies, they are going to put across you in some different ways, right? So 2 plus 2 is 4, so 3 plus 1 is also 4. So if you want to practice really what exactly is going to be your, you know, dynamic programming technique. Yes, Navloor, I'm just gonna share this program. Just give me a moment. So here you go. So you need to actually solve these 50 problems, right? So dynamic programming is not that easy for everyone, right? In the very first go, it has recursive solution. So you need to know how you can solve the problem recursively, first of all. When you know how the problem can be solved recursively, thereafter, you have to implement memoization or the tabulation technique. So what I'm trying to say is recursion in the interviews, why it is going to be so much important, because of, you can say, dynamic programming. All right, so why it is so important. So I'm gonna share this link across the chat, and I want all of you to attempt these 50 problems. So we have the solutions also for these problems, okay? So I'll be trying to work on one more algorithm tomorrow, right? And we'll see how we can implement dynamic programming once again. So anyone with any query here in the today's session, guys? Let me even push this program over the GitHub. So tabulation, you have to implement yourself, guys, right? So Navnoor, what I think is we can have a query session maybe on it's gonna be Thursday or Friday, right? So we can have a query session. So we can just discuss all the queries here and there. Let's wrap up the course first, and then we'll be able to kind of attempt those queries. So in the meanwhile, you can just WhatsApp the queries at the same time, okay? So I'll take it offline as well. So Lavish is kind of solving the problems. He has been sharing the problems for the try data structure. I don't know if you guys solved the yesterday's problem in a way of it that tabulation or memoization, which takes less time. So Gurlibleen, Malika, Navnoor, Prab, Shivam, guys, I request all of you to utilize this time in a maximum manner, right? So Navnoor, couple of sessions there. So I think two more sessions are left for me. One with the dynamic programming and one with the time complexities evaluation for a couple of sorting algorithms here and there. And a general way to give you guys one of the hints that how you can evaluate time complexities, right? So that's what we are left with. So thank you guys. We shall meet tomorrow once again, right? And I'm putting this session smaller because I have another session at 10 a.m. right? So that is the reason I'm putting these sessions a bit smaller. Thank you guys. Thank you so very much. Have a wonderful time. Please do not forget to code, right? So it is most important for you to code in this time. All right. So utilize your time, code these data structures well. Thank you guys. Thank you. Bye bye.